Hello everybody. Today we have a little bit different agenda here. I got the news that China is ready to launch Chang'e 6. Okay, this Chang'e, this in Chinese I didn't know. When I made a video for Chang'e 3 and 4, I was reading Chang'e, not Chang'e 6. Today I'm going to explain to you the quick summary of all the moon mission China did so far, from Chang'e 1, 2, 3, 4, 5. So we know when China launched the Chang'e 6, we have complete background of what's going on. We understand what China is trying to do with the moon project. Okay, Chang'e 1. This is a long time ago. I think almost 10 years ago or something. This the first moon mission was to establish the navigation system. Okay, how China did navigation system is you have Earth here, and satellite fly very far away. The moon is 380,000 kilometers, very far away. Okay, so how do you know where it is and how fast it's going? This is very important, and China adopted the method that this issued the X-ray pulse and launched multiple satellite and detect X-ray satellite, and it's calculate location. If you keep calculating location, you know the speed too. So that's the way. Usually GPS system, you are on the surface of the Earth and you use multiple satellites to determine your location. The same thing, but this is outward space, and moon is here. It's very far away. You need exact navigation system, otherwise it's fail to get into the moon orbit. Okay, landing is after you get into the orbit. The going to the moon is not that straightforward, because you leave the Earth orbit, go all the way. There is a so-called L1 Lagrange 1 point, then moon. And what Lagrange 1 point means, the gravity pull from both sides. And L1 point is when both gravities equals, right? And that means when satellite go, you have a Earth gravity, so you have to push hard using the engine to keep going. But once you pass this, you have to shut off the engine, because otherwise what's happened is moon's gravity pull satellite and increase speed. And you can't have too much speed. Okay, the reason is this. Suppose you have a moon here and you don't go directly into the moon, you get into orbit distance, right? Intended orbit distance, and the speed has to be right. If too fast, it's going to be ecliptic orbit. Okay, and too small, it's going to crash. And also this position is important too. Like 2000 NASA sent the satellite to the moon and crashed multiple times. And one time India sent satellite and it was way off, so it went very far away, and several years later finally came back by moon's gravity and crash. Okay, so getting in orbit is not that easy. It's you need to get into the proper distance at the right speed. So the speed adjustment you have to do. So you need to know where the satellite is and satellite speed, and adjust so that you can get into the orbit. Getting in orbit is not easy. The NASA failed multiple times, and India failed too. So what happened is, last time India, you have Earth and the Moon. They launch around the Earth and adjusted, make it elliptic orbit, slowly keep doing that, and finally reach to the Moon and get into the Moon. And this takes about 1 month. And you can't use this method for the human. The human cannot stay in the space 1 month and come back another 1 month and stuff. Okay, but India was successful using this safe method. Israel, I believe Israel company also successful getting to the orbit by same method. Japan too. The Korea used a very clever method. The Moon is moving around the Earth, and they shoot the satellite way out of the Moon's orbit, very far away. Then it's eventually come back by Earth's gravity, and Moon moves this much that time, then capture into the orbit. Okay, and they were successful, but this is I think it's very small chance of success. This it's risky. It's but this one is only 1 week to get to the Moon's orbit. If you go straight like a China, about 2 days. Okay. Apollo did it in 2 days same way, but they didn't have this kind of technology to calculate this kind of GPS system, right? The space GPS system. What they did is they have Earth and the Moon, and they have a telescope set to the faraway star. Okay, and this angle and this angle, they kept this angle same. Make sure it goes straight. Okay, this is the Apollo method, and Blue Origin talk about using the same method also, but this is crazy. This is very inaccurate, and Apollo time they didn't have an onboard computer, so how do you calculate this trigonometries, right? And this trick, they asked a MIT professor, and the MIT professor said, okay, I make a calculator for you, and many long wire of magnetic. This has a magnetic nuts here, and you feed machine, then you can calculate. This is like a trig table. You don't expect astronaut to do trig calculation on paper. Then they use this trig calculator. Yeah, that's at least the document said they did that, but I never heard that astronaut ever did that. Right now, you can have a desktop computers. You can hit the key and calculate the angle. But this method there's no way. It's you don't want to risk your life using this method to go to the Moon. Okay. But Blue Origin. The problem is the Elon Musk, Blue Origin, SpaceX, whatever. They don't have any data or technology from Apollo, because Apollo said, and NASA said, we lost everything. Can you believe that? They said they lost all the technology they used. Well, anyway, it's a 1969 technology, so even if they lost, it's okay. But you know, it's crazy that Blue Origin tried to use the same method documented in the Apollo. I mean, this using X-ray pulse and make a GPS system. We can do that technology. This is a Chang'e 1. The established this method, and China confirmed it work well. The second objective of Chang'e 1 was to make sure the orbit change around, you know, ecliptic, circular, those orbit change, and this always done around the Earth. Okay, when they shoot the satellite, sometimes it's off the orbit, they make a correction. To make a correction like this elliptic orbit, here you reduce the speed, then it's fall faster. But you have to add a speed and make a change correction, otherwise you cannot get into this. So there is a certain adjustment necessary, and we do that around the Earth, but on the moon it's so far away, 380,000 kilometers away. It takes about 1.5 seconds by microwave. So under such a condition, if you don't know where the satellite is relative to the moon, how can you make an adjustment? This kind of manipulation, it's verified they can do it in Chang'e 1. Okay, now Chang'e 2. What was the objective for this mission in China? China said this carry a lot of fuel. Why? Because it went to the moon, get into the orbit, and it's circle around the shortest possible circle and take a photo and make a complete map of the moon. Okay, and that's a preparation for landing operation Chang'e 3. Okay, to decide where to land, and also make another map circling a little bit far distance. So this is a manipulation of orbit. Chang'e 2 they did multiple times. And one more interesting thing is they did very elliptic orbit. The reason is this distance become like 10 to 20 kilometers, very close to the moon surface. And China said they took all the picture of the Apollo site. Did they find the Apollo on the moon surface? Well, they never say anything. China doesn't want to say anything, but they have these photos. Okay, so they know the truth. Okay, so this kind of manipulation, that's the first one. The second mission is there is a L2 point, Lagrangian point, this Earth and Moon, and L2 point. What's L2 point? L2 point is this L2 point behind the Moon is going to circle around the Earth with Moon together, and there is a two gravity, Moon and Earth, both gravity together. And also once this goes circle, it has acceleration here. So this acceleration and the gravity by both Earth and the Moon equals, that's the L2 point. The L2 point, if you go to L2 point, you can just keep circling around the Earth behind the Moon, right? Okay, but that's not what is important here. What China did is they circles communication satellite vertically around the L2 point. Okay, so how is it possible to circle L2 point vertically? Well, you know, the Earth is actually, this is very far away. The gravity goes this way, right? But the moon's gravity goes this way. So both together, you add up, total gravity is this way. Okay. Now this component is this one. That is the satellite get the component of gravity from moon to the center of the orbit. So why they do that? Why you need this vertical orbit like that? Okay, this is a preparation for Chang'e 4. When you land on the dark side, the back of the moon, you cannot get a communication. So China is already figured out how to do it. This is a communication relay satellite, and relay satellite can see the back of the moon and the Earth both together. Okay, so back of the moon, lander and rover moving around. Rover communicate with lander. Lander communicate with the relay satellite. Relay satellite communicate with Earth. Okay, so this preparation, Chang'e 2, okay, verify that you can leave the moon orbit and go into this vertical orbit around the L2 point. Okay, so this is a preparation for Chang'e 4. Okay, and third mission for Chang'e 2 was that the preparation for Mars mission. Okay, this is the sun and Earth and the moon going around the Earth. Okay, now after L2 point, this Chang'e 2 left the moon orbit and got into sun's orbit. Why is that? You go around the sun. Okay, the reason is actually the half is my guess, because they don't have much. China doesn't say much about why they did that. From Earth to almost other side of the sun is huge distance. Can you communicate? If you need to communicate, what kind of antenna and what kind of energy? Solar powered battery is enough to communicate? Okay, this situation happened. The Mars is here and Earth is here. When you land on the Mars, can you communicate with Mars from Earth for this distance? This is across almost the diameter of Earth's orbit around the sun, right? So this has to be tested out. Make sure you can communicate before they send anything to the Mars, because otherwise communication is dropped off and you don't know what's happened, and that's it. It's a failure of the mission. So to test very long distance communication, Chang'e 2 went to the sun's orbit and go around. Okay, so China does step by step a lot of experiment in order to prepare for the next step. Chang'e 3 was a landing mission. Okay, so on the moon around the north, the facing Earth, it's landed. And the way it's communicated is lander communicate with, this is a satellite that carried the lander to the moon, act as a communication link and communicate with Earth. Okay, so it's never communicate directly from lander to Earth. It's always go through, because this satellite is pointing dish antenna to Earth all the time, and another dish antenna here is pointing this lander, and you need to have a dish antenna pointing proper direction. Otherwise, you know, the dish TV, if angle is 1 degree off, you totally lost that signal, right? So this is very important to have a dish antenna pointing correct way. And this Chang'e 3, I said the E again, Chang'e 3 is actually analyze the component, the atoms of the surface material. Then the spectrum come out, and this spectrum looks very unique. It's not like anywhere on Earth. It's like component mix is totally different from Earth. Okay, so there is the scientists guess probably moon is not created from the part of Earth. It's totally alien. The big stone came and became moon. Okay, but the definite proof come out when China got a sample from Earth, from the moon. Okay, but this is very interesting, and Chang'e 3 also analyze underground using this vibration detection method, see what kind of layers exist. Okay, so I'm not a geologist, so I don't know the details, but there are a lot of data detected. Okay, now Chang'e 4. This was a landing on the back of the moon. So moon, this is the face. It's landed here on the other side, and you have vertical circle circulating communication link satellite. So from here, the lander rover always move around, but the rover always communicate with lander. The lander communicate with this communication link, and this communicate with Earth. Okay, so China found the back of the Earth is somewhat different from front, but again, the composition of all the atom element spectrum is not like Earth. It's totally different. Okay, so now they need to get sample, and they got a sample in Chang'e 5. And it's strange, NASA is asking China to share the moon sample. So I don't know why. I thought NASA has a lot of moon sample, big rocks and soils and so much, but they want sample. And the problem is the Congress passed a law saying that NASA cannot share knowledge, anything with China to block off all the information about NASA's technology and stuff. So China said, well, you have to change the law, otherwise giving a sample to you is going to be illegal. Okay, so it's stuck there. NASA wants a sample from China, and this sample is from the back of the Earth again. This is the face, and they landed on the back. And the way it did is, it's carried the return ship, and lander is separated to return ship. Return ship circulating around the moon, and the lander landed, and no rover. Okay, but this lander has a return unit. So after collecting the sample, return unit goes up and pass that sample box to this return unit. The return unit go back to Earth. So they found the definite proof that moon is foreign material than the Earth, because they found a kind of rock which doesn't exist in the Earth, and this is a definite proof. And also the age of the moon is about half of the Earth. That means you have a Earth going around a sun, very lonely Earth. One day this moon fly somewhere, from somewhere it's fly near the Earth and captured into this Earth's gravity and became moon. Most of the moon in the solar system are probably the same way. It came from outer space and it's just captured by the gravity. So it's adopted kids. It's not like Earth's own kids. The DNA is different. Okay. So far they discovered this much. But before Chang'e 5, what China did is one more thing. It proved the technology that when you come back from moon to Earth, remember L1 Lagrange 1 point? After you pass, Earth's gravity speed up so much, and it's tend to be too much speed to directly enter into Earth's atmosphere. If it's getting to the atmosphere without slowing down, it's going to burn out. Even the high temperature protected metals can't stand it. So what China did is it's use slight outward angle to bounce it back, then come back, and second time around get into the Earth orbit, then land. Okay, so this bouncing back, this angle and speed is very critical. If it's too short, then it's still too fast and it's burned. If too far, it's bounced too far and it come back long time. It takes long time to come back. So this is tolerance is about 1 degree angle. It's very critical. So China tested using Chang'e 5B first, and this was not officially announced, but later they talk about this. They did this verification that you can come back using this bouncing method. This bouncing method is not written in anywhere in the Apollo. I don't know how Apollo came back, but the Earth's gravity is so strong. After L1 point, it's just speed keep increasing, unless you have a powerful engine to decrease the speed. But you know, you don't have that much fuels, because it's a round trip from Earth to Moon and the Moon to Earth. So use this technology. The China used this technique of bouncing and getting into the orbit, kind of thing. So during bouncing, a lot of energy is dissipated by bouncing action. Okay, so that was tested here by one of the satellite, and this is not officially announced, but they did this test before Chang'e 5. Okay, so Chang'e 5 is the first time it's come back, and the sample also, China discovered the H helium-3 trapped into the rock. Okay, and H and O also trapped into the rock. That means if you release this from the rock, you can get the water and oxygen, and this is fuel for nuclear fusion. Okay, so China discovered that many already. So this was a very exciting project. Now, what is a Chang'e 6? Actually, Chang'e 6 is the backup of Chang'e 5. In case Chang'e 5 failed to bring back the sample, Chang'e 6 go and try to get the sample. But Chang'e 5 was successful. Chang'e 6 is going to have an additional mission. I think its mission is collect more sample from different location, and this is my guess, they increase the size of all the spaceship is the equivalent weight that carried astronaut. So you know, you have to send something and land and get up to the orbit and come back. You have to repeat several times, make sure it's always works, right, before you send a human. The China announced they are going to send astronaut to the moon surface by 2030. Now NASA is rushing very much. They want to send somebody to the moon before China sends somebody. I wonder why they did it in 1969. So why you rush? But after China's announcement, NASA go crazy. They somehow try to do it earlier than China. Okay, but it's dangerous to send somebody with just 1 or 2 times testing. My feeling is China keep repeating this: go to the moon, land, get up to the orbit, and come back, and bouncing before you get into the Earth orbit. This has to be repeatedly done successfully. Otherwise, how much confidence do you have to send a man, right? Okay, so that's all for today. If you like this video, please subscribe and wait for the next one.